Chief speakers and distinguished guests and ladies and gentlemen, welcome to the forum. It's my honor to be the forum moderator today, and I'd like to introduce the first keynote speech. As we know, Qualcomm is the world's leader in CDMA manufacturing and wireless technology, and also Qualcomm is the top 2 mobile phone IC design houses. And as the market of EV will grow in the future, we see that one day Qualcomm will also become one of the most important companies in the semiconductor industry. So what's the Qualcomm's strategy for the future? Now let's welcome Michael Campbell, Senior Vice President of the Engineering Department of Qualcomm, to give us the speech. Please give him a round of applause.
Good afternoon. Thank you for having me, Mr. Wu. It's my honor to be here, sir. I have been coming to Taiwan now for approximately 25 years. Not all with Qualcomm, other companies. And I have always been amazed at the innovation, the spirit, and the beauty of this country. So the spirit of the beauty and the innovation of this country is always shown. I want to talk about the endless opportunities that are available with the advancing technologies that Taiwan is helping bring to market. COVID in the last 3 years really has taught us all that digital technology, digital communications is critical. Many people around the world only worked from home over the last 3 years. It was only possible with advanced technologies and secure networks. If you look at this, you can see that the transportation industry is transforming, the energy industry is transforming, health, human services, smart cities, and energy. All these industries are changing the world as we know it. The 5G networks that are available in many cities today can communicate to a private 5G network where factories can run autonomously. And those autonomous factories can either go lights out or they can be run by very few people and just a few robots. In ASE, a company, a partner of ours in Kaohsiung, they have a 5G factory. That factory is standalone, but the internal communications are run off of 5G technology. That is an innovative use of the technology and how we can bring different changes to the world and still have excellent use of manufacturing. The automobile is what I'm going to center on for a few minutes here. The automobile is one of the key factors in the changing industry. Automobiles went from having a couple hundred, maybe, dollars of IC content in them to having thousands, if not multiple thousands of dollars of IC content in them. As we go to Teslas, as we go to BMWs, as we go to Porsche, EV cars, the content of a car can go up to $5,000 of semiconductors in that car. Taiwan produces well over 60% of those semiconductors, and that makes it a critical part of the global supply chain. 5G is a way, especially for cars traveling down the road, to become autonomous. Cars need to have automatic feedback from the vehicles around them and from the industry and for the local areas. With 5G technology, that communication lag goes to almost zero, and the car can react almost instantaneously to changes in the environment, changes in the road, or changes to cars around it. In this very simple example, a car or anything talks to an individual device. Oops, it doesn't. Okay. Talks to a device. That on-device has to have AI technology built into it. So the faster we can process through the CPUs, the more powerful our AI engine is, the more we can do on the device. But the device needs to talk to the outside world. 5G allows it to talk to the edge of the cloud, and then the edge of the cloud can be hardwired into the big cloud. But for instantaneous communication, you need the ability to go from the device to the edge of the network and back again. The car is again the center of the piece. As you know, Qualcomm has recently announced that we've got a $30 billion pipeline of advanced process technology, most of it coming from key industries here in Taiwan. Those new cars provide digital services, smart transportation, immersive entertainment. My wife's new car has 6 touchscreens in it. I don't know why any car needs 6 touchscreens, but it has it. It would be perfect, I guess, for my godchildren, but okay. That immersive infotainment allows you to have 6 different streams of programming. It allows you to make data calls, touch calls, do gaming while you're driving down the road. That kind of data information changes requires high-speed, low latency data communications across the globe. Each one of those cars that is partially autonomous these days has a fairly large AI engine in it. The AI engine has to make the decisions on the fly from edge network data and from data from around it, surrounded by the cars. We at Qualcomm and many other companies here in the exhibits are partnering together to bring that technology to your car, to your washing machine, and to your universities. In the near future, by 2035, an industry study predicted that there would be a $13 trillion electronic pipeline. That pipeline is going to be headlined by the healthcare changes, smart cities, industrial, agricultural, manufacturing, automotive, retail, energy, and et cetera. Those changes, those industries have to grow significantly to have a $13 trillion pipeline that's enabled. My favorite thing, as I grew up on a farm, this picture of the farm being harvested by multiple combines with no operators on board, being driven by 5G technology, AI engines so they can know where each other are, is an amazing feat to improve the productivity of farms and allow crops to come to market regardless of the ability of workers to get to the field. That $13 trillion pipeline of electronics is a challenge for the entire industry to surmount. That challenge really will bring change. Change is the necessary engine for innovation and for growth as we go forward into the industry. A study by McKinsey showed that the semiconductor industry will grow to $1 trillion by approximately 2030. In 2021, the size of the semiconductor worldwide industry was $500 billion. So in the next 8 years now, we have to double the size of the industry. If you think about what that means double the number of semiconductor fabs, double the number of assembly companies that we have to build those fabs, double the amount of transportation we have to use to get those semiconductors to market, double the number of IDMs that have to bring that semiconductor to market. As you can see, automotive is the largest percentage gain in electronics. We've already talked about why. Putting an AI engine in there, putting large microprocessors in it, really drive significant growth in the semiconductor content. But that's a small potato compared to compute and wireless. The wireless industry will continue to grow somewhere around 25% by that time period. Compute will grow and is the largest powered sector by that market, especially high-powered compute. This is a partial, please remember that, partial map of the semiconductor supply chain. This incomplete list still gives you a very clear view of just how global the supply chain is. From Japan to Taiwan to China to Korea to the United States to France, Germany, Spain, Italy, Israel, the semiconductor supply chain populates the globe. And as it continues to populate the globe, changes in economics around the world are sending to say, we want a factory here to have some balancing to the supply chain. That's fine. When we're going to double the industry, we have the ability to put a factory almost everywhere if we're really going to double this industry. What are we going to double the industry with? A few years ago, in 28 nanometers, most technology was planar technology. Planar technology can be explained by seeing the source that's labeled there. Can I highlight this? No. By seeing the source there, it was buried in the substrate. That limited the amount of voltage and the ability to control that voltage in the semiconductor. In 2011, we went to FinFETs. As we raised the source out of the fin, out of the substrate, we increased our ability to control the voltage. That allowed us to lower the voltage, lower the power required by the semiconductor, and make better use of the silicon area that we had. By 2020, in 2024, we're going to start seeing gate-all-around semiconductors. What gate-all-around does is put a ribbon of nanowires through the gate. Those ribbons of nanowires will be then better controlled. We can again lower the voltage significantly in the semiconductor, thus making the semiconductors even more efficient in the industry. There's two paths to get there. One is called device technology co-optimization. That's where we just continue to make the devices smaller. The other path is the more exciting path in many ways. It is really the 3D IC path. As we start stacking chips on top of chips, memory on top of logic, 3D memory on top of logic, backside power grids so we can control the power more effectively, and finally getting to chiplets, which companies like AMD are using today. That allows us to make better yield, more effective use of the silicon, and again, bring better products to our consuming public. 3D ICs are complicated, they're confusing, and they're a little bit magical to me still. But if you look at it, you bring a die into the bumping factory, and you basically stack two die on top of each other. That's the easy part of it. When you bring it in, but you start drilling holes through the silicon, it's called bringing a through silicon via. If you do woodworking, that's like taking your drill press and bringing a hole through the drill press and being able to touch the board below it. It's a lot more complicated than that in silicon, but that's the general concept. Again, you can bump that silicon, put the multiple die together, and in the packaging factories, the OSATs, we can put the final product together and deliver it to the customers. These are very complicated technologies, but this is what's required to take the next generation use of Moore's Law. Moore's Law basically stated that every 18 months, the amount of silicon the amount of transistors per millimeter squared would double. With standard shrinking technologies on just the die shrinking path, we're running out of steam. However, Moore's Law never said anything about not cheating. So by stacking die on top of die, we actually double the number of transistors per millimeter squared as you look at it by an XY construct. In 2035 or thereabouts, we're going to start tracking transistors on top of each other and truly do double the transistors in the same amount of area. But we have to practice to get there. It's going to be a long, complicated, complicated process where we're going to need the brightest minds, the smartest people to be able to drive that new technology. Taiwan has again and again shown it has the technology, it has the universities, it has the brain power to bring the new technologies to marketplace. I look forward to seeing Taiwan bring this to market and really being able to drive this technology for us, the semiconductor user. This just gives you a quick view of what's happening. Stacking a package on package is easy. Putting an interposer in there is also relatively easy in terms of today's technology. When we start to doing 3D ICs of interposers or with through silicon vias in place, it gets a lot more complicated. When we start doing wafer-to-wafer bonding, yet again, more complicated. And finally, when we get to 3D stacking by about 2035, 2040, it's going to be mind melding because it's very, very different technology. So I want to just say the semiconductor and Qualcomm are committed to Taiwan. The global semiconductor supply chain will continue to add value to this entire marketplace. You saw it trying to drive a $13 trillion market by 2035. Efforts are underway globally to grow the breadth of the supply chain, but if the industry is going to have to double anyway, where those factories go, doesn't matter. The technology that Taiwan develops will go to those factories because someone has to be first, and Taiwan is the most likely candidate to be first. The world needs a highly educated workforce, a very innovative workforce to bring these technologies to bear. I can say nothing but very positive things about your university, considering the number of people we've hired in the last few years here in Taiwan. They are amazing in terms of what they learn and how fast they come up to speed in terms of learning new technology from us. In Taiwan, we have built innovation centers. There's a booth back that way someplace with one of our innovation centers back there. Please stop by. And look at what the innovations are bringing. I believe the winner this year is building hearing aids, very small hearing aids with Qualcomm technology. So something that's easy, simple, but very useful to the world around you. Qualcomm will, again, continue to recruit and drive technology here in Taiwan. We, the semiconductor industry, however, need access to water and power. We're more than willing to help with power plants and et cetera, but we need that access. And you've been excellent in supporting the industry here. But as we grow, the more factories, it's going to become more difficult. And we all have to find better ways to bring green energy to the marketplace so that we can use those factories, but use them with green power and then continue to not pollute the earth around us. You've seen from most of the factories here in Taiwan, they're doing basically 100% recycled water. That recycled water keeps the groundwater from being polluted and keeps the total utilization of the factory down. But even those factories need to be able to reclaim some new water because steam just escapes somewhere from someplace. Taiwan is a key member of the Qualcomm supply chain. Thank you very much for being a key member. Come on. Taiwan is, basically in closing, Taiwan is a key member of our supply chain, and you're very well positioned to remain a pivotal portion of that supply chain globally as we move worldwide. That's the end of my speech. Thank you very much for having me.
Thanks to Mr. Campbell to give us wonderful speech. Thanks. And really, thanks to Qualcomm's commitment to Taiwan. Thank you.